Hey guys, thanks for joining me and coming to you with another presentation on molten salt reactors. The question is, are they the future or are they the past? Now, the nuclear industry has a habit, I dare say most of the time, of basically repackaging something and putting it out there as new. Now, Um, this is true with the new small modular reactors. This is true with the pebble fuel, the triso pebble fuel. This is true about many things with the nuclear industry. And we're going to go over a few things here with molten salt reactors. Okay, here this is at Terrestrial Energy, and this is a company that's working on a new thought of a molten salt reactor. Okay, we'll go ahead and read here. The IMSR plant uses proven molten salt reactor technology with patented enhancement for commercial scale thermal and electrical energy generation. The IMSR plant uses molten salt fission. This high temperature fission technology, classified as Generation 4 fission technology class under international treaty. Generation 4 designs will use fuel more efficiently, reduce waste production, be economically competitive, and meet stringent standards of safety and proliferation resistance, according to Generation 4 International Forum. Molten salt fission technology uses a molten salt as the coolant and the fuel. Conventional fission technology uses a water coolant circulation through a highly pressurized system to cool solid fuel elements, which are the signature technology features of nuclear power plants today. A nuclear reactor requires a high-performance coolant for safe and efficient commercial operation. Molten salt have exceptional thermal and stability, making them superior reactor coolants compared to water. This permits safe, high-temperature, and low-pressure reactor operation, which is crucial for heat supply to the industry, to reduce the cost of nuclear energy and transform the efficiency of nuclear electric power generation. When a molten salt coolant and molten salt fuel are used in combination, the reactor has the potential to incorporate the powerful virtues of passive and inherent reactor safety as well. This is important to safety, social license, and commercial performance as well. I will say this is the one positive of this design, in my opinion. Okay, this is one of the most important parts here. The IMSR improves upon earlier molten salt reactor designs by incorporating key innovations that create a reactor suitable for commercial industrial use and ready for near-term deployment. The IMSR cogeneration plant design incorporates many aspects of molten salt reactor operation researched, demonstrated and prototyped by test reactors at the Oak Ridge National Laboratory. Okay, now we're going to go off here. Show you something here. Okay, sorry about that. Okay, on the right, you'll see an Oak Ridge publication. That one, I believe, is dated in 78. The one on the left is dated, released on 1971, and it is the actual index of all the abstracts that have been released on the molten salt reactor from Oak Ridge, Tennessee. And I'll go ahead and kind of show you guys that one. Okay, it's here. That is that number. So you want to put these, you can't just look up general Oak Ridge, Tennessee molten salt reactor, because you'll get a bunch of different publications. And each one's different. And each one covers like different things that they were working on. But this is kind of like the overview one. 217 pages long. I won't scroll through it. I'm just going to kind of show you how it's set up. This is pretty much how it is set up for each time they did a publication. You'll see each has a paragraph or so, an abstract, just a basic overview of what they did. So if you want to look up this stuff, you got to look for each specific one. Looking for one won't tell you the whole story. Okay. I will tell you in 75. Where am I to? 1975. Gosh darn it. They released publication. I think it was this one. This might be the 78 one. This is the 78 one. Find the other one. That one. Fingers crossed. Let's see here. 78 too. But I believe this one, yeah, you can at least see that they talk about tellurium embrittlement. A lot of times these publications won't even list tellurium embrittlement as an issue that they're working on. But this pretty much has an issue in the whole core, the whole main part of the reactor. So you got to research tellurium embrittlement or tellurium segregation. Very important when talking about a molten salt reactor. Okay, now this company says that they're designing this to be able to replace the actual core every 7 years. Okay? But the issue with that is if they are going off what the Oak Ridge experiments were, then it would happen in much less than 7 years. Then you would have to design a specialized metal to build these reactors to actually be able to handle the stress of this reaction and the corrosion. Usually in normal water-cooled reactors, they use what's called hydrazine, and that's what keeps the corrosion down. Otherwise, it would do a similar thing, and the reactor vessels wouldn't last near as long. Most people don't even know that. Okay, hydrazine goes up in spacecraft as well. Keeps corrosion down. Okay, so every 7 years, it's a 7-year operating period. Also ensures that the material's lifetime requirements of other reactor core components are met. A challenge often cited as an impediment on the immediate commercialization of MSRs. Impediment, sorry. So that's what is the issue, is that it breaks down. But they're citing as graphite as the issue. They don't even really mention tellurium embrittlement. Okay. So this is basically a small modular reactor. It's a molten salt reactor. And if they build it with a nickel alloy, it's going to have the same issue. Okay. Everything looks great on paper, but in practice, it's not the same story. Let's see, and also, let me show you something else real quick. And I might do another video just on this place. But this is a place most people have never heard of. Okay, this is a commercial molten salt reactor that most people that even talk about MSRs don't even know about. Okay? This was this plant here had, this power station here had, on one side it had this plant, and then on the other it had a coal plant, and they were sharing the turbine in between them. Okay, full power was achieved in July of 1963. The facility shut down on September 27, 1964 to resolve reactor problems 1 year later. Okay? And eventually, 1966, 3 years later, was announced a plan to decommission because of the issue of tellurium embrittlement. Yes, normally graphite expands and contracts. And even back then it would last longer than 2 or 3 years. But the main issue is tellurium embrittlement, not the graphite. So don't be confused about that whole point on MSRs. If you find people that you're debating against, you're talking about MSRs, use this information. This totally shuts it down, because otherwise they have a point. The passive system is a great idea. The fact is that the fuel and the coolant together, molten, and it's a salt on top of it, is not a great idea for metal. I mean, isn't that an obvious thing? Not even knowing about the fission products and it interacting with the nickel. Because that's what it is. Tellurium is a fission product. Okay? So come to find out, well, this is hearsay. I tried to look into this, but from what I hear, and if anybody can share something with me on this, let me know. From what I hear, a man was injured so badly, and he got leukemia, and they had to bury him in a lead-lined casket. Okay? And if you look this site up on the federal government payout, they've paid over $1,035,000 to the families and the workers of this site for damages from being harmed. Okay? Most people do not know that. Alright guys, well, if you found this interesting, if you want me to do a video on this place, I got some more coming out on on thorium, a couple more planned. We're going to go back to Robert Mueller and his climate stuff. So that's what's coming up next, and if you guys have anything to say about this, let me know in the comments. Please like it, it helps, and subscribe if you're not subscribed. Thanks for watching all the way to the end, because most people don't. Alright, thanks guys. Bye.